Now we get into the part of our data analysis where we look at what we call standard deviation and standard error. So if I've actually highlighted here just the changes for each one of the trials that I did for the $4 detergent here, and we're going to look at essentially the spread, because that's what standard deviation actually looks at, the spread within a single group. So for the $4 detergent, we had a spread of data ranging from a change of 1, 2s, 3s, 5s, another 3, 4, 4 and 2. So if we did a histogram of that data, here's the change, whether it was 1, 2, 3, 4, 5, and this is how many times it occurred in our different trials for the $4 detergent. When you look at a histogram of that, this is what it would look like here. And as you can see, we had a spread of data around what our average was. And this is where we look at standard deviation, how far our values deviated from the average that we actually calculate. Now the average I calculated was a value of 2.9. So if this is 3 here, then that means my average would sit somewhere in around here. And of course my values actually deviated from that average to both sides. If we actually drew that like this, we get what we call a normal curve. Now this is where standard deviation comes in. It looks at the spread of that data either side of our average that we calculated and sees how far it spreads. The further it spreads out, the more error you have. So essentially you're not repeating and getting the same answer every time you run that trial. If you get different answers and they vary widely from the average, then that means your trial is not repeatable. It has a lot of error in it. You're doing the same experiment over and over again, but you're not getting the same answer. You have a wide range of data, and that's where it comes into our standard deviation. So this is how we calculate it. To calculate standard deviation, you simply have to give Excel the instructions to use that formula. So first of all, I'm just going to go equals in my standard deviation box, and then I need to tell it I want to calculate standard deviation. Now it already knows how to do this. You just have to give it the instruction StD, and that will actually bring up anything with standard in front of it, and all of these options for standard deviation come up. Now the one that you want is this StDev.s, because that's actually based on samples, and it ignores any text that you might select. So double click on that one and it will open up some brackets and go, okay, standard deviation of what? Now you have to tell it all the values, the same as the average, the ones that you use to calculate the average, they're the same values you now use to calculate your standard deviation. So hold down your Control or your Command key while you select them. And again, you can see it just adds them in there with a comma between them. You could type them in, but honestly this is a lot quicker. Release the Command key or the Control key and then go Enter, and it will calculate standard deviation. Now while it does that, within that functionality there, it's actually working out the error, working out how far they're deviating from the error, doing a whole heap of little calculations in the background, and it comes out with standard deviation. Now, to copy that down again, you just select it, let it go to that tiny little black cross and drag it down. And then you have standard deviation done. Now your range, I'm going to explain in a minute why we do this, but for now, for those of you who just want the calculations, trust me, range is 2 times your standard deviation. So it's pretty easy, equals 2 times, little asterisk, whatever's in my standard deviation box, there's my range. And I copy that down. Now notice how we have a whole heap of decimals here we really don't want. Better off to make that a bit simpler. So if you go up here, you can actually tell it to reduce your number of decimals down, and it will round them down to about 2 decimals or whatever you need there. Alright. Now if you want to keep going and understand standard deviation, stay with the video. If not, just use this the instructions so far to get that into your Excel spreadsheet so you can move on. Okay, if you're still with me, I'm assuming you want to actually learn about what the heck standard deviation is. I'm going to give you a very bare bones version of it. You can go into it in a lot more depth, but just the basics. Standard deviation looks at how far our data spreads either side of the average. Okay, so there's our average, and a histogram, if you look at it in a normal curve, it spreads out either side of the average. It takes that data either side of the average and it divides it up into 3 parts either side. Each one of those parts is called a standard deviation. Now you might say, okay, well, how much is a standard deviation? Well, it's actually not an amount, it's a percent. It divides your data up into percents of your data. So first standard deviation, it goes out 34.5%, I think, from your average here, either side. Then it goes out another percent of your data further from that. And this last little bit of your bell curve here is actually equal to 2.5% of your data on the top and the bottom. Now that 2.5% is the important bit there, because in science, with you guys, we try and look at 95% of your data. We consider that to be good. And the last 5%, the 2.5 top and bottom, we consider is going to definitely be what we call an outlier and be an error. So we try and ignore it. So we want to look at 95% of our data and ignore the rest. How do we do that? Well, we calculate the standard deviation and then times it by 2. And if we look at that times by 2, we end up encompassing 95% of our data. We call that our range, what we actually want to include in our data. So often when they talk about what your data is for a trial, they'll actually, instead of just giving an average, they'll give you a range, which means they'll quote for a range. They'll quote your average, which in this case is 2.9 for this value here, plus or minus 2.45, sorry. And if you have 2.9 plus or minus 2.45, you end up encompassing all of this area here, which is 95% of your data. So sometimes when we do talk about it, we'll talk about it in ranges rather than just the average. Because when you say it like that, 2.9 plus or minus 2.45, well, you think about it, that means it's actually ranging from 2.9 almost down to 0 up to 5.3. So when you think about that, that's a very big range for that data to be spread. In other words, in this case, I'd say we've got a heck of a lot of error. So your range really does paint a picture, but another way to paint a picture is with standard error, which is what the next video is about.